Okay, so let's have a look at problem 1423, maximum points we can obtain from cars. So for this problem, basically we can use a method called sliding fixed size window after we transform the problem. So first I'll read through the statement of the problem, and then we will look at the transformation and the idea, and finally we write the shortcode. First, let's look at the statement of the problem. So there are several cards arranged in a row, and each card has an associated number of points. So the points are given in the integer array called cardPoints. So in one step, we can take one card from the beginning or from the end of the row. We have to take exactly k cards. So our score is the sum of the points of the card we have taken. So the assumption is that given the integer array cardPoints at the integer k, so return the maximum score we can obtain. So here the return is the maximum score. So it does not care about the details about how we select the cards. So and the cardPoints and the key are given. So these are the information a priori available. So let's look at the examples. So in example 1, so the return is 12. So basically we can choose 5, 6, and 1. So we first choose 1, then choose 6, then choose 5. So in example 2, as the cards has equal points, so we can choose either this two or this two or the two at the two ends. So we get 4 points. So in the last example, the card points has length 7 and the k equals 7. So we just return the sum of the card points, in other words, the array. So before we look at the idea, let's look at the constraint. So the card length can up to 10 to the power 5th, meaning that we need to try to do it in a linear or slightly higher, but not to an order of n square. So the last one is that k is greater or equal than 1 and less or equal than the length of the array. So that's a consistency assumption. So with that said, let's look at the method. So the method is a sliding window method. It's a fixed size window. It's actually a relatively easier problem. So the idea is here. We think in the other direction. So we assume the length of the card is n, and we just need to find a contiguous subarray of length n minus k with minimum sum s. Then we just need to return the sum of the array minus that minimum sum s to get the points we can obtain. So here is an illustrating example. So assume we have a card like this. So this is a variation of example 1. So we have k equals 3. So actually we can find that the length is 7 and total sum is 22. And we want to find a subarray with length 4 and with minimal sum. So here this corresponding subarray is 1, 2, 3, 4. So what we want to return actually is 22, the total sum, minus the sum of 1, 2, 3, 4. So we get 12. So that's similar to example 1, but demonstrate the generic case, because in this case the corresponding peak is 5 and 1 and 6 in the two ends. So I guess with that said, we're ready to write the code. Again, we want to emphasize that we can make this transformation due to the fact that the cardPoints array is given at first, so that we can track the length information and the total sum and do the reformulation of the problem. So with that said, let's look at the code. The code will be very simple now. For this, for our purpose, let me first track the information about the length and about the total sum. Let's call it total. So it's a sum of card points. Then what we want to do actually is we want to find, I just introduce another variable just for convenience of fixing the idea. So we want to find length L subarray with minimal sum. So we just need to run this and then get the minimal sum and return the total minus that minimal sum. So if L is equals to 0, so we're just going to return total. So this is a special case. And then we're going to iterate. So we just need to do a linear scan and write it in a linear fashion. So we set result. The result means the minimal sum. And current. I'll first track the first L elements. So let's see, up to L. Then we do the sum. So this forms a base for our comparison. Then we're going to do an iteration. So for I in range, so L up to M. Then each time we're going to add the ith item, then subtract the I minus L item to keep the running sum. So the current, the result, let me first update the result, the current plus the card points at index I minus the item corresponding to I minus L. In other words, the most early item in the current window. Right, then the result will be the maximum of the result and the current. So after this loop, we're going to return the total minus the result. The result corresponding to a minimal sum of a subarray with length capital L, and the total minus this number corresponds to the maximum point we can get through picking cards from the two ends. So with that said, I guess it's good to check for the special cases. So what's wrong here? So here, here we need to return the minimum. So let's read. So it passes the first example. Now let's look at the second example. Second example, in some sense, is trivial. It passes the second one. Now let's look at the third one. The third one is also a edge case because the length of the card points equals the items we are going to pick. So this is 55. So now we are in a position to check the generic case. Let's do it. Yeah, it passes the generic case. I guess that's about it for this problem. So overall, the problem is sort of simple after we do the reformulation, but the condition at which that we can do the reformulation is that the whole card points array is given and the key is given a priori. So that's about it for this problem. Thank you very much.